In this video I will show you a very simple application of Kirchhoff's loop rule. Now I will just show you the idea what Kirchhoff's loop rule is telling us, but in the way that we're going to be using it in circuits is going to be a little bit more complicated than this. This is just a very simple illustration of what Kirchhoff's loop rule is telling us. All right, now I have a battery. Okay, and let's say, what should we do? Let's make this to be the positive side, that's the negative side of the battery. And I have a thick wire here, a thin wire here, thick wire again, and the left thick wire is this identical to the right thick wire. Now, I have labeled the different parts of the circuit. In order to apply Kirchhoff's loop rule, you need a loop, as the term implies. And I know around a closed loop, from Kirchhoff's loop rule, I know around a closed loop, the delta V, the total potential difference, is 0. This is Kirchhoff's loop rule. Now my loop is going to be the following. I'm going to start from point 1 and I'm going to go to 2 clockwise, and then 3, 4, 5, 6, 7, 8, and then back to 1. It is important that you go back to 1. You have to go to your starting point to close the loop. Kirchhoff's loop rule only applies in closed loops. All right. Now, if I make this trip around the circuit and I go back to the same point, I know that the total potential difference will be 0. All right. Let's see what I get. So I'm going to start. When I go from 1 to 2, I have a V final, which is V2, minus a V initial, which is V1, because I started at 1. Okay, so V final minus V initial. This takes me from 1 to 2. Plus, so this term is the delta V across this part. Now I'm going to go from 2 to 3. V final minus V initial. And as you may have been able to guess, I'm going to be doing that for a long time. So I'm going to go from 3 to 4. And then I'm going to go from 4 to 5. All right, let's see. 6 minus 5. And this is the last one. V1 minus V8. And this should be equal to 0. This is Kirchhoff's loop rule. Okay? I go from 1 to 2, from 2 to 3, from 3 to 4, blah, blah, blah. And then I make it at the end of the day back to 1. And when I add all of these delta V's, I should get 0. Now, one way that you can apply this, if I tell you what is this delta V and this delta V and this delta V and so on until here, okay? So if I tell you all of these numbers and I tell you that the sum of these is 3, exact 3.0, then what this is telling you, what Kirchhoff's loop rule is telling you, is that V1 minus V8 is minus 3 volts. And V1 minus V8 essentially tells you the potential difference across your battery. So this is one way, for example, this is one way that you can use Kirchhoff's loop rule. If you know all the potential differences but one, you can use Kirchhoff's loop rule to find that one. And as I said, that was a simple application of the loop rule.